Greetings to lecturer and also my fellow friends. We are from Group 4 for Karyotyping Lab wants to present to you about our caricature and also karyotyping of chromosome. So without further ado, let's get fresh knowledge with us. So these are our group members. We are consist of 8 members in total. So for the topic of the day, we'll be mainly discussing on chromosome caricature and also karyotyping. This video will be consist of 2 parts, and this first part will be discussing mainly on chromosome caricature. So for table of content, these are the things that I will be discussing on. Okay, so let's begin. So as you can see, this is chromosome 4. And do you know that chromosome 4 spans about 191 million DNA building blocks or base pair and represent more than 6% of total DNA in cells. Surprisingly, it's also contain about 1000 to 1100 genes that provide instruction for making protein, which is essential in our body. Interesting fact about this chromosome is that trisomy 4p is a rare chromosomal disorder in which all or a portion of the short arm P of chromosome 4 appears 3 times. So this is our caricature for chromosome 4, and it has Popeye as the representation for chromosome 4 and includes white head, shoulder band, and long body. For your information, chromosome 4 carry the gene that can cause several of diseases, but let me tell you a few things about this. So firstly, Ellis van Creveld syndrome, which is an inherited disorder of bone growth that results in dwarfism. Secondly is the fibrodysplasia ossificans is caused by the mutation of genes ACVR that affect body's mechanism causing fibrous muscle to be ossified. Next is narcolepsy, which is a sleep disorder that makes people very drowsy during the day. Moreover, these genes also carry serious disease such as Huntington's disease that cause breakdown of nerve cells, and also genes that cause Parkinson's disease, which have difficulty with balance due to brain disorder. Alright, let's move to the next part, which is the type of aberration that occurs in chromosome 4. So first is the HTT mutation that causes Huntington disease, involve a segment known as a CAG trinucleotide repeat. Normally, this segment is repeated 10 to 35 times within a normal people, but people with Huntington disease though, they repeated about 36 to 38 to more than 120 times. That is quite a lot. Moving on, chromosome 16. So, do you know that chromosome 16 spans about 90 million base pairs and represent just under 3% of total DNA cells, and humans normally have 2 copies of this chromosome. However, having a copy of extra gene is known to be trisomy 16, and the most common health issue is miscarriage. And this is our caricature for chromosome 16, which represents the cake, which has dark triangle below centromere, dark at lower part, and head. For chromosome 16, the critical gene is normally known to be Crohn's disease, HbA1, HbA2, alpha thalassemia, FMF, familial Mediterranean fever, PKD1, polycystic kidney disease. Okay, so first thing first is HbA1 and HbA2 alpha thalassemia. These are instructions for making a protein called alpha globin. And next is the PKD1. So mutation in the PKD1 include deletions or insertion of DNA building blocks and alteration of one or more base pairs. Most PKD1 mutations are predicted to produce the abnormal, small, non-functional version of the polycystin protein. As I mentioned, chromosome 16 also include the Crohn's disease, so it is a type of inflammatory bowel disease. It causes swelling of the tissue in the digestive tract. Last but not least is the familial Mediterranean fever, which is an inherited disorder usually characterized by recurrent episodes of fever and peritonitis. So in chromosome 16, the first aberration involved is the deletion. So deletion normally occurs when segment or chromosome is deleted. So these deletions of genes, chromosome 16, caused normally by Cry-Do-Cat syndrome. So this disease may start appear during pregnancy, and the affected baby will have high-pitched cat-like cry and small head. The baby also have difficulties in breathing and also feeding. Next one is the duplication. So duplication is normally can cause Charcot-Marie-Tooth disease type 1. So person with this disease affected will experience weakness and atrophy of the muscles of the lower legs, normally beginnings in the childhood. And last but not least is translocation. So translocation is also a type of aberration in chromosome 16, and translocation will happen when there is a segment of chromosome broken off from its original location and attached to another chromosome. Somehow this may lead to Robertsonian translocation disease. A person who being affected will have difficulties in getting pregnant and can develop trisomy and also other genetic abnormality. So for the next part, I will let my friend Sharon to explain more about karyotyping. Take it away, Sharon.
Hello guys, for the next part is chromosome karyotyping. Let's go. So you guys must be wondering, what is meant by karyotyping? Karyotype is the normal nomenclature used to describe the normal or abnormal, constitutional or acquired chromosomal complement of an individual tissue or cell line. As you can see, this picture shows normal chromosome arranged on a karyotype of a man. All chromosomes were arranged and aligned in pairs numbered 1 through 22 from largest to smallest. This arrangement helps scientists quickly identify chromosomal alterations that may occur in a genetic disorder. Based on the picture, chromosome 1 until chromosome 3 were categorized as large metacentric group. Chromosome 4 and 5 were categorized as large submetacentric, while chromosome 6 and 12 were categorized as medium submetacentric. Chromosome 13 until 15 were categorized as medium acrocentric, continuing with chromosome 16 until 18 labeled as short submetacentric. Chromosome 19 and 20 labeled as short metacentric. Lastly, chromosome 21 and 22 labeled as short acrocentric. And finally, we have chromosome X and Y, which are sex chromosomes that shows that the person is a male. Now here we have the abnormal karyotype. After we managed to align all the chromosomes, we found out that there are 3 X chromosomes which lead to abnormalities usually called meta-female syndrome. This genetic condition is mainly caused by non-disjunction during cell division, which sperm cell or egg cell does not form correctly. For its treatment, usually based on their symptom, for example, if the symptom is that they are having learning disabilities, we have to find new ways to teach them. Chromosomes can never be eliminated, but if exposed to the right environment, they will survive in a normal life despite having too many symptoms that they will show. As you guys can see here, these are the common symptoms which they will have. For example, for them being tall, low in weight, having mental retardation, ovarian failure, menstrual irregularities. Sometimes they can cause mental or development challenges. This also leads to academic disabilities, trouble socializing, and even stress. Now we know that the mother can undergo genetic testing when they are pregnant. The test is such as amniocentesis, is where fluid is extracted from the uterus to detect possible birth defects and can provide the diagnosis of XXX syndrome before birth. But at the same time, from the research outlook, we found that there is no cure for meta-female syndrome because it occurs when the fetus is developing.
Trisomy X, also known as XXX syndrome, and characterized by the karyotype 47XXX, is a chromosome disorder in which a female has an extra copy of the X chromosome. A relatively common disorder occurring in 1 in 1,000 women, trisomy X is rarely diagnosed. Fewer than 10% of those with the condition know they have it. Diagnosis of trisomy X is complicated by its mild presentation. Many girls and women with an extra X chromosome show no symptoms significant enough to inspire formal testing. Trisomy X occurs via a process called non-disjunction, where the normal process of cell division is interrupted and produces gametes with too many or too few chromosomes. Non-disjunction is a random occurrence, and most girls and women with trisomy X have no family histories of chromosome aneuploidy. Advanced maternal age is mildly associated with trisomy X. Women with trisomy X can have children of their own, who in most cases do not have an increased risk of chromosome disorders. Women with mosaic trisomy X, who have a mix of 46XX and 47XXX cells, may have an increased risk of chromosomally abnormal children. First diagnosed in 1959, the early understanding of trisomy X was that of a debilitating disability observed in institutionalized disabled or mentally ill women. Thank you for watching. Like and subscribe if you would like to view more of our videos. Have a nice day.
Action! Apa ada tu ni?
That's all from us. Thank you guys for watching.